This video contains demonstrations and discussions on the processes or basic processes that will be involved in solving radical equations. Again, we are solving radical equations. In short, in simpler language, we are going to try to look for the possible value of the variable which can make the equation true. And since it's called a radical equations, we are going to, these equations actually involve radical expressions. So this is still the processes will actually be the processes involved in solving linear equations, involved in exponential equations, wherein we just need to balance both sides of the equations, will still be followed in solving radical equations. To do that, let me share to you the first six basic examples of exponential equations. It's already here in my material. Okay, so we have here practice exercise A for the first part of uh, of solving radical equations. As you can see, all items from 1 to 6 involve radical expressions. And as a matter of fact, these radical expressions contain variables. So we just simply are using the commonly used variable x so that we could actually just be focusing on the processes and the steps. Of course, it could be represented with another variable, but I'll be choosing the variable of x. Okay, so take a look of that of these examples. These are all equations. So we are guaranteed that the left-hand side should be equal to the right-hand side or vice versa. So since we are already guaranteed that they are both equal, we are going to look for the specific value of the variable that which can make the equation true. Actually, at just first glance, especially in number one, we could automatically solve for the value of x. Okay, in number one, let me write it here. In number one, we are given with the square root of x is equal to 7. Okay? Again, in just one glance, probably you can come up with already with the value of x that can make this equation true. And that is, the value of x is 49. Because when you simply substitute the value of x, which is 49, in the given equation, so it will become square root of 49. And we all know that the square root of 49 is 7. That is why the answer here is actually 7. But there are some instances, part here in this practice exercise in the next two more videos, wherein at first glance you cannot automatically solve for the value of x. So we are going to use now the a process which could actually be applicable to all types of radical equations. And that is actually to neutralize here the radical expression. The radical expression here, its index is 2, hence the name square root. So to neutralize this, we simply need to square this. Okay, so that it will actually be following the law of power law of radicals, wherein this would become, of course, square root of x can be I'm going to write this here on this other side. Okay, you may check the other videos on simplifying radical expressions or rational exponents to have a review for this process here. So again, x, the square root of x can be rewritten as an expression with fractional exponent x to the power of 1/2. And since it is being squared, we will use the power law here. So it will become x to the power of 1/2 times 2 is 2/2, or simply x to the power of 1. And basically, we can write it as x, neutralizing already the radical expression. But of course, in discussions on linear equations, also involved actually in exponential equations, we need to make sure that when we try to manipulate the equation, whatever is applied on the left hand side must be also applied on the right hand side. Since we took the square of the expression on your left hand side, we need also to square this side here. And then the next step is x equals to the square of 7, which is 49. That is why the answer earlier, this is actually the proof, mathematical proof, that in our guess and test or a trial and error, we have solved 49 as a value of x. To know, to guarantee better if our answer is correct, simply check it. By means of checking, we substitute whatever value that we can get here to our given equation. And since square root of 49 again is 7, this means that this is a solution. Okay? As you can still remember, when we talk about solution, it's not actually the process involved. When you say solution in an equation, it is the value of the variable which can make the equation true. Okay, so let's just try to apply the same processes for the rest of the items here. For number 2, we have square root of x is equal to negative 10. Again, to neutralize the radical expression here, we square both sides. Whatever you do in the left hand side, do it on the right hand side or vice versa. So the square root of x is just x as represented here earlier is equal to the square of negative 10, or negative 10 times negative 10 is 100. Okay. So this is the value of x that we have solved. But the question here is this a solution, or will this value make the equation true? Of course, we need to check it. That is why there is always the purpose of checking, because we may solve any value of the variable, but not all of them, or not the it is also possible that the value of the variable solved may not make the equation true. Let us try to check. Checking again, substitute in on the given. So we will have here x is 10. It's positive 10. It's not, it could be negative 10 if we have a negative sign here outside. So square root of 100 is 10, and then we apply negatives, negative 10. But since there's no negative sign outside, the answer is 10. Is this similar to our given? No. Our given is negative 10. Okay. Why? Um, Again, do not get me wrong. Of course, there are instances wherein the roots of numbers may be negative, but in this case, it will not make the equation true. Therefore, we have solved x, but x may be labeled as not a solution. Okay. This is not a solution because this doesn't make our equation, original equation, true. Okay? That is the real purpose of checking. So always check your work. Let us proceed now to number 3. And number 3, we have the given here. The negative square root of x is equal to negative 10. Okay. Before we apply the squaring of both sides, there is a proper consideration on the equation first. That is actually to make sure that one side or both sides may contain only radical expressions. If there are some operations or coefficients which are not part of the radical expression, you may try to simplify them first. What I mean is this negative sign here outside. So we could actually divide this by negative 1 so that we could actually cancel that out, leaving negative x over 1, or simply, I mean, it's not negative x, leaving square root of x over 1, or simply square root of x. And of course, following the properties of equality, we also apply it here. And then we can already cancel out the negative. And then this is equal to 10. Since there are no more items surrounding the radical expressions on the left-hand side, we can now proceed to squaring of both sides. Okay, so square of both sides. Again, this is x. And the square of 10 is 100. Checking. Let's check it here. Square root of 100 is 10. And take note, there is a negative number, negative sign outside. So again, square root of 100 is 10, and then there's a negative sign outside. This makes the left-hand side negative 10, similar to your right-hand side, which is negative 10. Therefore, unlike number 2, number 3, where x is 100, is a solution. This is a solution. Right? Number 4. In number 4, what is added to the radical expression on the left-hand side is an integer 2. Okay? You may say, I could square both sides, sir, of the equation. You may do that. And since you already know how to square a binomial, you may create a trinomial there, perfect square trinomial. But of course, you could always do this. We could always remove the 2 here by subtracting 2 on this side and applying the properties of equality. We also subtract here 2. The purpose for this is to remove this one, and we only leave square root of x here, and this would be equal to 8 minus 2, which is 6. As you can see, and if you're going to compare this equation here and the equation in the given, this is way easier to look at or to square than the given equation. Okay? And then we need to start squaring both sides. So we have here x is equal to 36. Another purpose of checking is actually to determine whether the operations or the processes involved in your solution are logically and mathematically correct. As I mentioned earlier, the equation form here is easier to look at than the given. But there might instances wherein from this area here, going down here, you have made an error. So you need to check your answer. So this is our answer here. But we are going to check this not here because again, as I mentioned, you may have committed an error as you move forward. So you always check it using the given. Using the given all of the time. So let's have 36. Square root of 36 is 6 plus 2, 8. That is why the answer now is not just an answer, but it is definitely a solution. And check your answer using the given equation because if you will check whatever is next to it, if there are errors committed in the process, you may say, I have checked it properly, but you have checked using an incorrect equation. So always use the original equation. Let us continue to our second to last item. So our second to last item contains multiple uh, coefficients outside the radical expression. So you have 2 square root of x minus 3 is equal to 11. Okay? Well, you might say I could divide both sides by 2 so that I could remove the coefficient here, just like what happened in number 3. We divide both sides by -1. But of course, yes, it's still logically and mathematically correct, but you might experience here fractions. And not all of us are very, what do you call that? Um, not mass the not the word is not master but very comfortable when dealing with fractions. So I would suggest to first remove here the negative the 3, the -3 or the -3. To do that, could simply copy this one, -3, and we simply add 3 to neutralize this and make it 0. Following the properties of equality, you will also add 3 on the other side. And then this would become 2 square root of x is equal to 14. And then this is the time that you could divide both sides by 2 to remove the coefficient 2 here. And then this will result to, I'm just simply going to write it here, square root of x is equal to 7. This is similar to item number 1, but since we are still here, let's square both sides. Your value for x is actually 49. Again, let's check it. But we are going to check this not in this area, but always to the given. So square root of 49 as the value of x is 7. This would become 2 times 7 minus 3. We don't know yet if it's true. 11. So 2 times 7 is 14 minus 3. 11 equals 11. This is now the proof that this is really a solution. Okay. Last item. Last item is the cube root of x is equal to negative 4. You might be tempted in saying this is similar to number 2, wherein the right hand side is a negative number. Therefore, this is not a solution. Okay? You might get tempted with that, but just need to determine first what type of radical expression is being presented. In number 6, it's not square root, but it's cube root. Okay? So before jumping into different conclusions, try to uh, neutralize this. So instead of squaring this, we are going to cube this. Cube. Okay? And then do the same thing on the other side. So this would become x, because again, that would become 3/3 or 1 is equal to the cube of negative 4 is negative 4 times negative 4, positive 16 times negative 4, we have negative 64. And then let's try to check. Okay, take note that this is a cube root. When you say cube root of a negative number, that real number exists. Okay, only when it's square root of a negative number that the number do not exist. So the square root of the cube root of negative 64 is negative 64 is actually a perfect cube of negative 4. So this is a proof that this is actually correct. So the key in solving radical equations is number one, please determine the type of radical expression being presented. Number two, you apply squaring, or in terms of number six, cubing both sides. Manipulate using the properties of equality, and whatever your answer is, do not settle down. Always check using the original or the given equation. And if you could actually check it, that would be the time that you could actually conclude that your answer is not just an answer, but a solution. But if it will not make the equation true, we have two different situations. Number one, the solution doesn't exist. And number two, there are errors in your computation. So this is again the first video for radical equations. We still have two more. I have added um, different practice exercises that will involve additional processes just for you to master the skill of solving radical equations. Be excited. But before we go to that video, please use this video as part of your review. Thank you very much. Have a nice day.